Hello and welcome to Session 6, Add Measures to Semantic Models in Power BI. I'm Andrew Conniff, a Microsoft technical trainer specializing in data and AI, and today we are discussing calculations in Power BI. Let's get calculating and jump right to it. In this session, we will discuss DAX concepts and syntax and calculated measures, columns, and tables. DAX analysis expressions, or DAX, is a programming language that is used throughout Microsoft Power BI for creating calculated columns, measures, and custom tables. DAX is a collection of functions, operators, and constants that can be used in a formula or an expression to calculate or return one or more values. Using DAX to solve calculations and data analysis problems can help create new information from data already in a model. And in Power BI, we use different calculation techniques and functions to create measures or calculated columns. The key is to know how and when to apply them. Having a basic understanding of when and how to use each technique allows the creation of robust and highly performant data models. Measures in Power BI are essential for performing calculations and summarizing data within a DAX model. They enable the aggregation of values across multiple rows, allowing for the comprehensive view of the data. So measures are commonly used in data analysis and offer a wide range of functions, including sums, averages, minimums, maximums, and counts. What makes measures particularly powerful is that they are not pre-calculated. Their values are determined only when used in a report, and the visual is visible. This dynamic nature ensures that measures update in real time, responding to user interactions within the report. This behavior is one of the key advantages of Power BI reports. By creating measure calculations and combining them with filters and other visuals, users can explore the data and generate insightful visualizations. This flexibility empowers users to uncover meaningful insights and delve deeper into the data based on their specific needs and interests. By default, Power BI automatically aggregates numerical columns using functions like sum, average, min, max, count, or count distinct as the default summarization. This automatic aggregation is called an implicit measure, indicated by the sigma symbol. You can modify or disable implicit measures by adjusting the default summarization settings. Explicit measures, on the other hand, are intentionally created measures where we define the calculations in the formula bar. With explicit measures, we have full control over the calculation logic. They're indicated by a calculator icon. And quick measures are predefined calculations in Power BI Desktop designed to assist beginners. While there are limited numbers of available calculations, we can easily select the appropriate fields, and Power BI generates the measures for us. This helps us learn DAX and helps us achieve what we want to do. A calculated column in Power BI is an extension of a table that uses a DAX formula to evaluate values for each row. It allows us to augment the data from different sources by creating a column that didn't originally exist. For example, let's say you have a sales transaction table with a column like order ID, product ID, quantity, and unit price. There's no column for the total sales amount per order, however. So using DAX, we can create a calculated column called total price by multiplying the quantity and unit price values for each row. Calculated columns are a type of custom column. We can create custom columns in three ways. We can go to the source query, we can use Power Query, or by using DAX in Power BI. Creating a calculated column in Power BI using DAX doesn't require semantic model refresh to see the changes, unlike the other methods. However, it's important to limit the use of calculated columns due to potential performance impacts and increased data refresh time when dealing with large semantic models. Calculated tables in Power BI are tables that are created based on DAX expressions or calculations. Unlike regular tables that store data, calculated tables are generated on the fly during query execution based on the defined DAX expressions. Calculated tables can be created manually by writing the DAX expression or using functions like calendar auto, as shown on the slide. Using calculated tables can extend or enhance the data model by incorporating additional columns or performing complex calculations. They're useful in scenarios where we need to generate new tables based on existing data or perform calculations that are not easily achieved using regular measures. By leveraging calculated tables, we can provide more flexibility and analytical capabilities to our reports and dashboards. The fundamental difference between a calculated column and a measure is that a calculated column creates a value for each row in a table. For this reason, the calculated column can only operate over columns that exist in the same table. So for example, if we have 1,000 rows, it will calculate 1,000 values in the calculated column. Calculated columns values are stored in the Power BI or PBIX file. Each calculated column will increase the space that is used in that file and potentially increase the refresh time. Measures are calculated on demand. Power BI calculates the correct value when the user requests it. Measures do not add to the overall disk space of the Power BI PBIX file and are calculated based on the filters that are used by the report user. These filters combined to create the filter context. So we create measures as needed. If we need a persisted column, consider creating a column in a Power Query before choosing a calculated column for a model optimization. That's not to say that calculated columns are invaluable, but use them sparingly. Let's go to a demonstration of creating DAX calculations in Power BI.
Now let's take a look at using DAX to perform some calculations. So the first thing I'm going to do is create a salesperson calculated table. So a calculated table is created in the modeling tab. We can say new table, and then you can see we have the table name, and we're going to give the name here salesperson, and it's going to be from our salesperson performance table. So we're creating a table from a table, and then we select check mark and it will create the new table for us. So we've created one table from another table and we used DAX to do that. So in the data pane, we'll notice that the icons are a little bit different. You can see there's a little calculator right next to that showing that it is a calculated table. We can now make some adjustments. If we go to the model view, right, we can see a salesperson table is available. And what we want to do is we want to create a relationship between salesperson employee key and sales employee key. So it's popped up here. Use the key. So last time we took the sales person performance, make sure that those work, and we routed it through the regions. And then we've made a copy, and now we're going to do some additional calculations. And in this case, we no longer need to have any relationship here between salesperson performance and sales. So we're getting rid of that. And now we do have a salesperson connection. And we're going to do calculations. So if I go to the table view, I can say new table. And what I want to put in here is, and you'll see this calendar auto is the one that we want. And we're going to put a 6 in there. And so this is going to give us calendar auto formatting specifically that we're going to take advantage of later. So this returns a single column table. It has date values. And so the function is going to take a single argument, the last month of the year when emitted the value is 12, and we put 6. And so that's going to be June as the last month of the year. That will be our fiscal year. So we also have 12 a.m. as the time on there. So we're going to do some formatting to make this make a little more sense for how all of our dates will work. What we want to do here is create a calculated column where we're going to define our year. So we're going to go into our columns. We're going to say new column. So on our date table, new column. It's going to open up our window. So here we have how we can define our new column. And so what we're going to want to do is put in some data for this. So what do we have here is a new column called year. FY is the fiscal year, and then the year is the date. And then we have the time with the 6 on there showing the 6 months, 1 month increments. And here we now can see the fiscal year showing up. So it's FY, that's our formatting, and then the date, 2018, right? And then if it's greater than the 6 months, it goes, we're going to go back to that. So it's going to shows us how to calculate the fiscal year based on it ending in June. Now, what we want to do is add new columns for the quarter and the month. And here we have quite a bit more information. So here we're saying if the date is less than 3 months, right? So we're dividing this up into different sections, 3, 6, and 9. Those are our quarters. We'll have 1 to 3. So if it's less than 3, et cetera. So less than or equal to is going to be the first quarter, second quarter, et cetera. Let's select the check mark, create our quarters. And the next thing we're going to do is the month. Go ahead and do new column, paste our formula. And here we are laying out exactly how we want the month to be displayed, year first, month second, with the abbreviation. Now that we have a bunch of definitions in here, we are going to validate our date view, and we're going to go create a matrix and just see what we've done so far. The matrix has the title there. Move this front and center. And then we're going to drag the month field into the rows directly beneath the year. And next we're going to drag the month in there directly underneath it. And what we see here is that you see this icon where I can expand all rows down. So we can now add the unit price to our table here. Right? And we see we have this average of unit price. And in the visual pane field, right, we can go to the values. We can select the drop down arrow, and then we have a bunch of other items that we can see. We see the average is selected. Okay, now we're going to create some new measures for the sales table. So we're going to go to our sales table and say new measure. And we're going to create a measure called average price. And it looks like this. So we're average of the sales units. We're going to go ahead and take the average of the sales unit price. We're going to create a new measure. There we have it there. And now we'll be able to see when we add this to our matrix table, we have average and average price. And we'll make a little bit more room. We're going to add another one. We're going to add median price. New measure, we'll add that one. And we'll add another new measure called min price. New measure. And if we have a minimum price, then we should probably have a maximum price. So let's create another new measure, maximum price. As you see, we can continue on adding all of the various calculations that we need as measures. So they get calculated when the visual is visible. And we have all of this information that we've added to our model. And that brings us to the end of our demonstration.
This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.